Waiting for Romer to get out. I have his phone. Hey, Jeff, I got Roman's phone.
Page 71.
Oh, yeah. Did you get alerted?
Yeah.
I didn't.
It worked for me.
Okay. I got a lot to talk about next, all right?
This could be you.
Remember we had talked about ions and the charges and charged atoms?
Yes.
Okay, so let me just go through and talk a little bit, and then you're going to do some reading on the section and take notes, and I have a lot to explain to you in detail, all right?
What page?
So we're going to be looking at ionic compounds, and the word ions is embedded in the word ionic, okay? So that's a good half of chapter 4 that we're going to be dealing with ions. Got it? Very important. Very important. So I do want you to read section 3.10, page 71, 72, 73, and 74. Read those 4 pages. I mean, read it. I didn't say talk. Get off of those frickin' cell phones.
Put your hair on. I'm waiting for Roman to walk out. It's gonna be legendary. I'm recording it. No.
Can we settle down, please?
We're 2 minutes in. If he takes the whole period, we lose all of this space. Ooh, we got it, boys. You're rolling now, you're rolling. Guys, read. Jeff. Yep.
Turn around.
You rolling, you rolling. We're 4 minutes in.
Oh, this is just for Emily.
Wow. You're so cool. Oh, I didn't say streaks. Oh,
I want to do streaks.
I want to do my streaks.
Yes, my streaks.
You put hearts all around it.
Yes. Not really, I get away.
Perfect. Okay, we're gonna make this cool together now. Okay. There's the hearts. We're gonna put every pink heart It's gonna take forever. Oh, what if filters are homo? I can't believe it. Big heart.
Actually, that was great. Oh, good. So,
Put hearts all around this picture and you're ruining it. There's gonna be one big heart right here. Yeah, we're 7 minutes in.
7 minutes?
7 minutes.
Why?
I want to use up all of his
battery?
that and his camera space.
What a good friend, bro. You're such a good friend.
Thank you. These streets are putting in a lot of work. These hearts don't even look like it's surrounding you. No! Oh my land! Oh boy, 3 a.m. Fuck. But. Yeah, man. Yeah, me too. Are you fucking homo?
Okay. Let's move on to the next part. All right. There's quite a few things that I need to show you in this section, all right? Okay. So, on your blank periodic table, we know where the metals are located and the non-metals. Am I right? Okay, so you have two types of ions. You have the positively charged ions, okay? Positively charged ions only come from metals. All right, so let's look at an example. So you have the neutral atom, okay? All elements start out neutral, right? So the neutral atom of a metal, okay, is what you start off with. And what happens is it's going to lose its electrons and it becomes an ion. All right? So I know in chapter 11, they're going to ask you which is larger in size, the neutral atom of a metal or the ion of the metal, which is going to be larger, the atom or the ion, which is larger in size. Take a look at your picture. This is the atom, this is the ion, this is the neutral atom. So what happens to metals? They tend to lose electrons, right? So when they lose something, what happens to the size? There you go. It gets smaller. Common sense. You start off neutral, you lose electrons, it becomes an ion. So which is larger and which is smaller? The larger is the atom and the smaller is the ion. We can see that. So when you lose electrons, isn't the size going to get smaller? All right, now, what if it's a nonmetal? Here's the neutral atom. Now, for nonmetals, what happens? They're going to gain electrons, right? And when they gain electrons, what happens to the size? It gets larger. So this is the neutral atom of a nonmetal. It's going to gain electrons because it's negatively charged and becomes larger in size. Clear enough? Yes. Okay. Then you're going to wonder, hey, Ms. Noda, how do you know what charges do the metals and nonmetals have? And so this is what you read in this section here. All right? So let's take some notes before we talk about the charges. You're going to write this down, and then I'm going to explain all over again. Shh. What's the matter? Chill.
Call me a dog.
Okay, all right, so we've got this part, right? Let me explain, and then I'm gonna enlarge each of these and explain, okay? All right, so let me go through this part first, okay? So all the elements that you're looking at in the periodic table starts off as a neutral atom, right? Okay, so basically it means that it has a net zero charge, right? Zero net charge, correct?
Yeah.
So if it's neutral, it's a zero net charge. Okay, now, for ions, you better know this vocab because I know it's on the test. This is a vocab on the multiple choice test. Ion. So what is it saying? It's a charged atom. It starts off neutral, becomes charged. Okay, so what does it say? It's a charged atom. You take, what is it? Neutral atom, and either you're going to add electrons or take away one or more electrons. Does that make sense? So whatever that number on that charge pretty much tells you you're either adding electrons or taking away electrons. If it's positively charged, you're going to be losing, right? If it's negatively charging, you're going to be gaining. So that's what it is. So a positive ion, what is that called? Cation. You're losing electrons, correct?
Yes.
If it's a negative ion, it's going to be called an anion, and you're going to be gaining electrons. So we got that, correct? Okay, now, let's talk about it further. All right. So for cations, only metals can be cations. So do you know where your metals are in the periodic table? Yes. Okay. Only metals can be cations. Okay. You've got metals and nonmetals. Only metals can be cations. Okay, here's an example. You've got lithium. This is a lithium atom, right? Because on the test, you're going to be asked, is this an atom or is this an ion? It's an atom when it's neutral. Okay, so this is an equation here. So this arrow is like your equal symbol in algebra. Does that make sense? So you have a lithium atom, okay, yielding, this is the lithium ion. See that? Isn't that lithium ion? Plus one electron. So this balances out. This is the ion, it's losing. Here's the one electron that equals to the neutral atom. So this is called the lithium ion. This is called the lithium atom. All right? That's right. So if it's a positive ion, you are losing electrons. Okay, and you can write this down. How's that? Okay, we got this?
Yes.
All right, next. Okay, so now you have anions. Only nonmetals can be anions. Only nonmetals can be anions. You've got to know this. All right? An example, you have chlorine atom, right? This is the chlorine atom, okay? And it's going to gain an electron. It's going to gain an electron and then equal or forming chloride ion. This is the atom. This is the chloride ion. Notice the spelling, I-D-E-N-D. The spelling of the anion is very important. If you don't spell it correct, then it's going to be wrong. Clear enough? All right. Remember, only nonmetals can be anions. All right. And the anion is what? It's negatively charged and it's gaining electrons. How about that? Okay, have we got that?
Not yet.
Now, the next thing you're going to say, well, Stella, how do you know what charges do the metals and non-metals have? Okay, so let me show you. You got that?
Yes, ma'am.
Okay? All right. So in your reading, they gave you the 8 columns, groups 1A through 8A. Do we see that? Okay, well, it's on page 74. How's that? Okay? So at the top of each of the columns, they tell you the charges. Does that make sense? Okay, and then they even write down the ions. All right? So, hold on. You are going to write this down, and then I'll explain. Okay? So each of your groups, oops, let me make that smaller. There you go. These are the ion charges in the periodic table. So each of your groups, see that, have their corresponding charges. But look at group 4. Group 4 has 2 charges. It can either be a +4 or a -4. All right? As time goes on, I'll explain to you when it's a +4 and when it's a -4. Got it? And then, if you notice, all the metals are positively charged. All the metals are negatively charged. And the non-metals, they have an IDE ending, like chloride, sulfide, oxide, right? So non-metals, the spelling in the endings of their names changes to IDE. So hence, that's why I have IDE ending. For the transition metals, they have multiple charges. Okay, so write that down. You better memorize this. Okay, so you got this down right. These are the charges for each of these columns, these groups. That's why we're only focusing on groups 1A through 8A because of the charges. And there's going to be some chemical properties that tells you why they have these charges. We'll learn that in chapter 11, okay? The naming of the nonmetals, the endings of their names changes to IDE. So that's why you hear chloride, sulfide, oxide, telluride, okay? It changes to IDE ending. Hence, so you gotta know that. The transition metals have multiple charges. What you need to do is you need to pull out your blank periodic table and label right above each of those columns. +1, see, this blank periodic table, you're gonna have a lot of stuff to write on it. Okay, so you have a +1 charge, +2, right, +3, plus or minus 4, -3, -2, -1, and 0. So on your blank periodic table, you're going to label the groups with their charges, right? Now, if you want to, you don't have to, like on this periodic table here, page 71, they go through and they write down the ions, okay? The symbols for the ions, okay, and their charges. You don't have to do that because you already know what the charge is and you know how to write ions, yes or no? Okay, so just make sure you put the charge at the top of the column. All right, don't play around and mess up, because what's going to happen is a lot of these in here, you're going to put down the element symbol and you're going to put down the multiple charges. What's going to happen is in chapter 4, when you get to this page, you're going to have to put down all the charges. Okay? So don't mark all over it, because a lot of these transition metals have multiple charges and you're going to end up writing in the boxes, okay? And I didn't want to put it up here. Read the next section. Actually, I'm just about ready to close.
Wizard?
Yes.
Or wizard? Hi, wizard.
Saturday. Yes.
Yo, this thing's been recording for 30 minutes.
Oh, great. Yeah, that's very important. So do you have, hold on, let me get a pen. Do you have the address of your,
Oh my god, I almost missed it.
yes, I will. Okay, so what's the boulevard location?
Camila, this has been recording for 30 minutes.
Yes, please, just say it's mine and I call the number.
It took like 10 minutes.
Are you still in your shit?
What? It says that
But now he's like very.
Legendary, but it's been recording for 31 minutes.
2014.
No.
4 years ago. 10. Actually, it was
No, so like, we're gonna record when Roman like walks.
Adam, she didn't say the name.
Cause like I wanted to.
What are you doing?
I was gonna come back.
They work.
How are you? Don't touch it, don't touch it. We're recording Roman walking through the door. This is lit. Get out of the way.
Roman's literally almost done with the test.
You mean open the door and say about my career? You're done with fucking.
We're recording Roman walking through the door.
Why? What's the
Hey,
point?
when he walks through, I'm gonna clap, okay?
This is his phone?
Yeah, this is his phone.
Recording the infrared.
Hey, when Roman walks through the door, we're all gonna clap.
Should I open the door?
33 minutes, bro.
Yeah.
Someone did that to my phone, but for an hour. Watch this, watch this. This is me funny.
Oh. Yo.
Your phone's been recording for 34 minutes.
I've been waiting for you for the past half hour.
How do you feel about the test you just took? I failed. Oh, he failed.
Probably failed. Damn, I have
30. No, don't delete it. There's so much